We are now going to use our laws of logarithms to simplify some equations here, or expressions here. All right, so we're going to write as a single logarithm by using the product or quotient of laws of logarithms, and then we're going to evaluate these. So I have two logs, they both have a base of 10, and as long as their bases are the same, we can write that as a single logarithm multiplying the 50 and the 2 together. You were multiplying those two arguments together, and then that's supposed to be a dot for multiply. 50 times 2 would be 100, so the log of 100 is what we're evaluating. And if you think about that, this is actually asking us 10 to what exponent is equal to 100? Well, I know that if I square 10, I get 100, so my answer is 2. So I get a bonus because I did it without my calculator. Now, this one's subtracting, so the rule, the quotient law, tells us we can keep our write as a single logarithm by dividing those arguments. So 700 divided by 70 would just be a 10. So we're evaluating the log of 10, and remember base, this is a common logarithm, base of 10. To what exponent is equal to 10? Well, that exponent would have to be 1. All right, part C. We're adding, so those would get multiplied, and then we're subtracting, so this would divide. So the log of, we would have 45 times the 20, and then divided by 9. All right, now 45 divided by 9 would be 5. 5 groups of 20 would be 100. We're evaluating the log of 100, which in part A we know is 2. Okay, the next one. Now my base isn't 10 this time, it's a base of 2, but they all have the same base. So these laws only work as long as your bases are the same. So we're going to have 50 times 18 divided by 225. Now let's see what we can do with this. We could use our calculator on this. I'm going to divide 50 by 25 and get a 2. I'm going to divide 225 by 25, and that would go 9 times. So that's going to give me 2 groups of 18 is 36. Oh wait, I can divide 18 by 9 and get 2, and 9 by 9 and get 1. That's going to give me the log of 4 with a base of 2. Okay, so those of you going off to college, if you have to do an entrance test for math, sometimes you have to do things without a calculator for those tests. So that's just a way to do those big numbers without using a calculator there. So this is saying 2 to what exponent? 2 to the question mark. Ooh, that doesn't look like a question mark at all. I think that's because I was already answering it. 2 to the 2 is equal to 4. So the answer here is the exponent that makes a 2 into a 4 would be a 2. All right, bases are the same. We're dividing. We can write that as a single logarithm, 162 divided by 6. 162 divided by 6. So what can that goes in? 6. Well, I could cut that in half, make that 3. Cut that in half, that makes that 81. Ooh, and I know 81 divided by 3 is 27. So that gives me the log base 3 of 27, and that 3 to the exponent 3. 3 to what exponent is equal to 27 is really what that's saying, and that's a 3. All right. We've got common bases of, ooh, this I think is a typo. I think I should have had a 6 here. I have to go and fix that. So we get 270 divided by 30 times by 4. All right, I can divide both top and bottom here by 10. 27 divided by 3. Ooh, 27 divided by 3, that's a 9. So overall, that's going to equal 9. And then 9 times 4 is 36. So as a single logarithm, that gives us a 36. Now, if you need to be using your calculator for this, it's okay. But ideally, we want to improve our mental math skills. All right, 3 to what exponent gives you, 6 to what exponent gives you 36? The answer is 2. 6 squared is 36. Moving on. Express in another form by applying the power law of logs. So the power law of logs was the one that said this exponent is also, could come down front and multiply that log. So this is equivalent to 3 times the log of x. Okay, try these questions, see how you do. This one should be 7 times the log of x with a base of 4. This one should be a half. This is equivalent to the log of x to the 1/2, because the square root is the same thing as an exponent of half. This will be 1/2 log x. The cube root is the same thing as an exponent of 1/3. So see how we're integrating our last unit with this unit? It's really important that you are on top of all your work all the way through. And likewise, the 6th root could be written as an exponent 1/6. So that becomes 1/6 times 3 times the log of x. And then I can actually multiply the 6 and the 1/6 and the 3 together. 6 goes into itself once. 3 goes into 6 twice, and 3 goes into 3 once. That's going to give you a 1/2 log x. All right, this one, I can write this one in another form by doing the log law in reverse. So that becomes a log of x to the exponent 4. Similarly, this one could be written as the log of x to the 1/4, or it could also be written as the log of the 4th root of x. So we've just practiced using that power law of logs.